Good morning, ladies and gentlemen. Welcome to our community event. And for our session, we'll be focused on AI and space-based Earth observation, and especially for the global disaster migration. And my name is Wenjiang Huang from Aerospace Information Research Institute and the Chinese Academy of Science. You know that as a global climate change, the meteorological and disaster, such as some torrential rainfall, and earthquake, and some biological disaster will happen more serious in these years. So, and for this session, we'll be trying to focus on how to use an AI and also observations for a resilient and future. We will try to share some practical experience. We'll be focused on how to use AI and space-based Earth observation has been used for especially for some quickly response across different disasters, such as some disasters about focus on some for the flood and wildfire and some public health risks and some others will be post some effects for the agriculture and environment. So, and we have some 4 presentations. I hope that maybe each presentation will be about 40 minutes. After each presentations, there will some questions and closing remarks. Now, we would like to begin our first presentation, and his director and Stren and Yang. And Stren Yang was director of our National Institute of Natural Hazards, the Ministry of Emergency Management of People's Republic of China. His research will be focused on how to use the satellite emergency technology and some operational system. By doing this, he has been try to use AI enabled remote sensing and early warming for the disaster teams. Now, Director Yang, the floor is yours.
Good morning, ladies and gentlemen. It's my pleasure to share my presentation here. I will focus on AI empowers remote sensing in disaster management for multi-hazard disaster chains. I will focus 4 points to introduce my presentation. About the current disaster situation, as we know, climate change is making disaster worse. According to the report of WMO, the melting speed of Antarctic glacier is 6 times now faster than it in 1980s. From 2023 to 2029, the global average temperature will rise 1.5 degree, and the rise probability is about 86%. I remember this data from 2017 to 2022. The probability is 17%. That means during 10 years, the temperature increase from 17 to 86%. That means how much the climate change now. And in other words, from 2022 to 2026, at least 1 year will become the hottest year on record, and the probability is about 93%. In other aspect, due to climate change, The frequency of the extreme weather events has increased by 40% compared to the 20th century. And the most important technology support to disaster management, satellites has made great achievements, and more satellites have been launched, and it gives out huge amounts of data. And now we can see the Earth by different means, such as including optical satellite data, radar satellite data, and thermal satellite data, and so on. And we can use sub-meter spatial resolution and hourly revisit capability remote sensing data. When we facing the area of remote sensing big data, the most important challenge is how to evacuate the resources of big data. According to this problem, AI can solve this problem to us. We know disaster management can classify the four phases, including prevention, mitigation, emergency preparedness, disaster response, and post-disaster recovery. And the AI can empower remote sensing data to solve about 20 tasks, including these four phases. This is a big data analysis graph. From this graph, we can find 4 clusters. For the blue cluster, it shows the major direction for disaster mapping using deep learning. For the red cluster, it shows the hot spots for emergency response. For the green cluster, it shows the major direction for using social media data. For the purple cluster, it shows the hotspots for identified of disaster chains. About the using system for AI to empower remote sensing, we found that it can make the work model transform from passive response to active early warning. The second, it can make disaster identification from see to understanding. The third is it can make disaster chain risk prediction from monitoring to forecasting. And the fourth is make early warning release from reactive to proactive. And this is a framework of early warning for disaster chains based on the use AI plus remote sensing. It includes 3 levels, including data layers, model layers, and application layers. Here I just list 3 application scenarios. One is the heavy rainfall-induced flood disaster chains. We can combine with high-resolution explosion identification. This can show the risk map for the flooding area. The second is the drought-induced wildfire disaster chain. We know forest fire have been caused by drought, temperature, wind, and vegetable. By using AI plus remote sensing, we can provide a risk mapping for the wildfire disaster. The third is earthquake-induced safety accident disaster chains. And it means after earthquake, some accident will occur because of the earthquake. By using AI and plus remote sensing data, we can provide the risk map for these chains. About the future outlook, we found the challenge we meet, including because the disaster area is complex, and how to provide the data quantity and the quality is very important. And also limited from the explainable AI and the complexity of geosafety issues. It's the main point for us to improve. For the next step, first we should capture disasters precursor signals. That means the pre-early warning index is important for us to use AI to identify and extract. The second is to detect the disaster chain detection agent for proactive prediction. The third is emergency decision-making agent for precise and efficient response. The last one is the general disaster prevention agent for cross-border long-term resilience. Thank you. Because the time limited, so I just give a brief introduction. Thank you.
And thank you very much for Director Yang for a wonderful and very interesting presentation of focus on the drought, flood, and earthquake monitoring. I think these applications will try to get how to use AI and also application for the disaster monitoring. Yeah, let's move to the next speaker. It's Professor Yu Qibai from Tsinghua University. And Professor Bai was focused on how to use geospatial data. Will focus on AI, enhanced Earth observation, focus on the wildfire and modeling and risk management, and especially under the and for the global cooperation. And Professor Bai, and please go ahead.
Yeah. Good morning, ladies and gentlemen.
Professor Bai, could you come here and please?
Yes. And could you advance my slide?
Do I need to for the presentation? Yeah.
To control the.
Yeah, maybe
okay.
come here for the presentation, maybe better.
Oh, okay, no problem. Tsinghua University and also GeoChina office. We would like to share our vision on the necessity for an AI-enhanced Earth observation, because we believe it is represents a new paradigm, how to empower the wildfire ecological and public health risk management, and which is definitely demonstrate a new opportunity for global collaborative disaster mitigation. I'm Bai Yuqi from Tsinghua University, China Geo Office, and Professor Chen Deliang is my colleague in the Tsinghua University. Okay, so first, let's starting from why we would like to focus on the wildfire, because as we already imagined that wildfire has become a systematic global threat in different continents and in different regions and even different seasons. However, there are some existing limitations with the traditional disaster reduction. We pay much attention on the fire suppression. However, empties or limitations have been observed with the short-term and even long-term ecological degradation, and also biodiversity loss, and also hidden damages to the human health. So that's the reason we believe not only rely on the satellite-based monitoring, but also we rely on the very accurate and reliable in situ data. Combine them and plus AI technologies, we could enable a new paradigm for the disaster reduction for the wildfire. and which is a very perfect alignment with GEO's mission. Well, actually, the reason for why we pay much attention on wildfire is because we can see it produce dramatic changes and negative impacts to the atmosphere, climate, ecology, and biodiversity loss, water and resources, and all the way down to human health and also even agriculture production. So that's the reason we would like to see, and also not only on the natural environment, but also for the children and for the elderly, the PM 2.5 composition and on the toxic, gases did bring a very bad impact to the human health for short-term exposure and also for the long-term indirect impacts. And Lancet reports has already presented how severe wildfire has been to the early days and also unexpected very bad impacts. So what do we need to do today? We believe not only relying on on the ground in situ data monitoring, like higher horizon towers for the local observation. We need to also complement with very high resolution space-bound micro perception. So combining the micro perception and also very local precision calibration, we hopefully to build a very solid foundation for the historical and also full cycle dealing with the wildfire event. And based on this solid databases, we are expecting several more core AI algorithms capabilities to cover the full life cycle. For example, the early warning, prediction, burn area expectation, smoke simulation, and all the way down to the human health, modelings. So I would like to quickly share with you some very recent interesting studies in this area. For early wildfire intelligence recognition, it deals with the limitations with the traditional detection. And so therefore, for this method, it has been validated very good performance based on the Lancet 8. The total recall could reach 81%. And for the fire severity intelligent grading, which is very important, because by a very accurate grading, it is very reasonable for the post reduction and also restoration. This study employs redwood forest, and Sentinel-2 accuracy is very much high. And for the burn area, which is a very good and also reasonable approach for you to understand the total impact of the wildfire to the natural environment. And this study, have been validated at the global test regions, daily operation, and also near real-time ready, which is a very good performance. For the smoke, we imply meteorological data and time series AI for the rapid and downwind PM 2.5 exposure prediction. So we can, this study can achieve average PM 2.5 24 hours in advance and has been well calibrated in California fire seasons for 5 years. And for global air pollution retrieval, we basically, in this study, fire attributed pollutant maps for smoke PM 2.5, toxic aerosol, surface ozone, and also heat maps have been successfully reviewed. Time series data more than 15 years, and exposed population surge is 27 times. And for the ecological and biodiversity assessment, this study reveals that nearly more than 10,000 vulnerable species and nearly 90% exposed to higher risk of 5 vulnerable species by 2100. And for the wildfire prediction and the detection, and we noticed that ECMWF already put operational validation global resolution at 9 kilometers and operation since 2023. It provides a very solid foundation for the near real-time prediction and for the wildfire detection. And for the human health risk modeling, we collaborated with some other domestic institutions from Chinese Academy of Sciences. They have successfully derived the long-term projection of wildfire at global scale to the 2100, and we further, derived the mortality projection in China. It was published in the Lancet Global Plenary. So as a conclusion, we believe we need a new paradigm for the disaster reduction and in particular for the wildfire. And so therefore we call for attention on a very new initiative, Geo-Wildfire Health Nexus. We would like to bring 9 components together and for the standardized data products and also for the international collaboration for many site validations. So we're looking forward to your attention and welcome you, for any comments and suggestions and participation. With that, I would thank you for attention. Thank you very much.
Yeah, and thank you very much for purpose by. As we all know that the global wildfire has caused very serious damage, especially to some forestry and grass, and also for the air pollution. So, and this research also have supported by the GEO and also do some application. I think we'll get how to do the wildfire at the early stage. And thank you. And our next speaker will and Dr. Jiao Jin and from the University of Berlin and just Switzerland. And her research will focus on how to use LiDAR, how to use LiDAR to do the disaster modeling. So Dr. Jiang and the next and flow, the first flow is yours.
Good morning, everyone. I'm Jin Jiao. Today, I will, on behalf of our team from the Chinese Academy of Sciences and the University of Bern. And today, my presentation is Tracing the Invisible, LiDAR in the Chinese Maritime Project and the International Maritime Circle Program. My presentation will include 5 parts. First is about the introduction about the atmospheric metal layers, and the second is the LiDAR technique used in the Chinese Maritime Project. And the third is the 3 landmark scientific breakthroughs for using the LiDAR. And then is the network from the China to the world. And the last is about the summary for the presentation. So first, we should know what is the atmospheric metal layers. Every day we know that many kinds of materials will enter into the Earth's atmosphere, and then they will obliterate into the atmosphere from the altitude range from 80 kilometers to 300 kilometers, and this region is very high for aircraft, and also it is too low for satellites. Also, it is a traditional blind spot for detection devices. So, the atmospheric metal layers lived in this region will be a natural tracer to help us to know the dynamics and the chemistry in the atmosphere of the ionosphere. So how to detect these special metal layers? The unique advantage, the unique device is using LiDAR. The LiDAR can detect the metallic ions from the altitude range from near 90 kilometers. And our LiDAR has high resolution with 96 meters and 33 seconds. Used this technique, we can obtain the many kinds of metal-like densities, and also we can make inversion to temperature, wind, and the density in the altitude range. And the second, I will show the technique of the LiDAR system in our Chinese maritime project. Before that, we should know what kind of ground-based networks in the world. In many other countries, for example, in America, in Canada, in Japan, Brazil, and Russia, they also have the ground-based devices. But in China, we also have a most comprehensive ground-based network. It will help us to observe the solar atmosphere, interplanetary space, magnetosphere, atmosphere, and the middle upper atmosphere. So based, okay, so. Sorry, the computer has problems. The last one. Yeah, they will open it in browser. Yes. Yes, thank you. Yes. Okay, sorry for the delay. I will go on for my presentation, and I will go on to introduce the LiDAR technique in our Chinese maritime project. So. I can use this one. Yes. Okay. So this is the map of our Chinese maritime project. If we want to make better forecasting for the space weather, we need to the ground-based detection, also combining with space-based detection and modeling together. And this is the LiDAR system in our Chinese maritime project. This LiDAR system can include 6 wavelengths. From this high energy LiDAR system, we can obtain the density, temperature, wind field from 30 kilometer to about 500 kilometers. And also we can obtain 6 kinds of metallic ions and atoms density. And this three station is our LiDAR station in our group. So our breakthrough in our LiDAR system is that we use solid state LiDAR technique, and we have high sensitivity. We can cover more altitude range from 8 kilometer to more than 300 kilometers. So based on our LiDAR system, I will show you 3 landmarks of our LiDAR system. First is about the sudden stratospheric warming. And this phenomenon is a sudden fever in a stratosphere, and also it will have influence on the mid-latitude region. For example, in China, in the US, and in Europe, it will have cold weather in winter in this region. For example, in our LiDAR system, we found a clear density disturbance related to the SSW event in the 2021. We have found clear density disturbance in Beijing LiDAR system, and also there is a high density jump at high latitude regions. So the SSW can help us to reshape the middle atmosphere density from pole to the mid latitude, and it is a factor previously overlooked in the climate and aerospace models. And the second, we can also see bite tracer all in the atmosphere. So what is the sporadic key layer? It is an layer include many kinds of metallic ions. It is like a mirror in the sky. It has better influence on the it can reflect radio waves. It can help us to make long distance communications, but also it has bad influence because it has obstacles with the satellite and the radar signals. In the right two figures, we can see the EIS phenomenon from a typical ionosphere devices. We call it ionosound. It is the frequency, but we can only see. Okay. I will show quickly about the pictures. And the third one is the EPB. It is a disaster for our human beings' life. So this is our LiDAR. This is our LiDAR observation of the EPBs. So the summary is that we have expanded our LiDAR system from the China to the world, and at the end is a summary. So the LiDAR has a big. It's very important for us to link the invisible coupling chain from the stratosphere to the atmosphere altitude range. So that's all for my presentation. Thank you very much.
Yeah, and thank you very much for Dr. Jin and for you and the work well focused on the LiDAR observations. And I think that maybe it will push the application of LiDAR applications and for the disaster monitoring. And the last one and the presentation will be made by and myself. I will give a presentation. It's okay.
Which one? This one.
Which one you didn't open?
We've had
No,
this
not
one,
this
this one,
one.
and this one. It's either these two. So it's either this one.
Maybe
This-
no, not this one.
This. Yes.
This one.
Okay.
Thank you. Thank you very much. And for our presentation, we have tried to focus on with Earth observation and AI, and then join for them, especially for some disaster, focus on and for the application in agriculture, especially for the yield loss caused by some disasters. As you know that we have tried as a global warming, the traced on especially for the global crop product and production and yield loss, especially and for the pest and disease, will be about, as FO mentioned, is about 40% will loss has been caused by the pest and disease. Also, as Dr. Yang mentioned that, and we also have some disasters for the flood and drought also will affect on about the yield loss. So for our research, we are also focus on the Earth observation and some international cooperation and with AI technology power to join together for the application. So, and for our research, we also get some cooperation with FO and GB, also with some international cooperation and organizations such as CABI, and them to do this research together. So we will try to do this at the global scale, and because some disasters will be at the global scale. So we will try to solve this at the global scale, because especially for some pests, they will fly from one country to another country. So we should do this at the global scale. So focus on this, we should try to know something about the habitat conditions, also about some, and just like the land surface temperature, also the land use, land cover, and also this will support us to do this research. So by this, and we have produced the non-scale and for the modeling about them and habitat modeling and the vegetation growth conditions. And then we will try to use AI and combine with the, and maybe about 10 years historic data. Then we will try to find how about this, maybe some major disasters caused in the past 20 years. Then we will try to know why this has been happening, how this has caused the yield loss. So we will try to get some results and to know how can we control it at a very early stage to do this. So by doing this, and we also get some cooperation and especially from FAO to get some field survey data for the validation and this data. And for example, and we have done this at the, especially and just like the Ethiopia and Somalia and all some African countries to support them for the early warning about the pesticide disease. Then, especially for some transboundary the pesticide disease at the early stage to guiding for the early warming. You know that at the very early stage, then it can control it and very well. So we have done this with the international cooperation, also with all the observations at a global scale. So and now we can control this, and just for the forecasting the pesticide disease, and now we can for the forecasting before it was an OCO about 30 days for the forecasting. So and this can be guided for the international cooperation and international control of this technology. And then they can do some and vibrate also and management. And about this, we also focus on some flood, also some drought modeling in the different countries at a global scale. For example, we also have done this for the Pakistan or for some other countries and try to use the optical and sound technologies. We also get the cooperation with just like Professor Guoqin Li, and because he will also show us the different kind of the and satellite data. Some of them the commercial, and some of them and also different resolution of them, and this data to support it. So we will try to focus on how to use also observations to guide it for the flood and for the drought, and especially for its effect about the crop yield, and for the different countries at the country level, also at the global scales to do this. So this also has been used for the Chinese government, and especially for the Ministry of Agriculture to guiding them to prevent the yield loss and in the different years to do this. I think that maybe why the Earth observation and the international cooperation and AI was very important, because you know that sometimes we should use the international cooperation because some of them are transboundary, and we cannot do it just in one country. We should try to combine in the different countries the data, then we can be joined together to do this. So and that's why we should try to do this together. And that's why we would try to maybe get some cooperation with international organization. I think that also the GO and FO and GB and CABI, they will try to support some member countries. Also, will support some fields and survey data. That's also very important to do this. So I think that maybe and this can get the application of the and some disasters, the effect about the crop yield is, I think maybe it will try to and support them to and face them and zero hungry and for this research. So and I think that and we also have shared our research data and by FO, also by GBF, and at a global scale. And this also has been used in some African countries, especially, try to use this to for the monitoring and early warning of some disasters, and then maybe they can get some control and by this early warning, this technology. So I hope that maybe it's very important for the international cooperation. Also, we should try to join the different kind of the data, not just Earth observation. We should also get some field surveying or some other meteorological data. Then we will try to, with AI driven, to do this data together. Maybe we'll try to solve this disasters and for the early warming and for the forecasting. So, and that's all for my presentation. Thank you very much. Thank you. Yeah. Yep. I think that about and for presentations, and I would like to and if you have some questions or some comments and from the audience, I hope that you can give some questions or comments about our research, and then maybe we can try to discuss how to use the Earth observation and AI can support us to do this better. And now, it's time for the questions and comments. Yeah, if you have some questions, you can raise your hands and then have some questions. Maybe you can ask some questions about which presentation or how about this, and then we can try to discuss some questions and comments. Okay, thank you. Yeah, thank you.
I have a general question, also coming from the plenary session above. All the application you showed, they deal with the public, with people. So I think that an important theme here is the explainability of AI. So in order to make sure that responsible people, government or whatever, they can understand what AI is proposing and trust it. But this theme has been only slightly touched in the presentation. Can you please give a comment on this, on the status of the explainability? So are we already there? Are we able to explain the results of AI to government or not?
Yes, about the AI application in disaster management, I just mentioned the limitation is the explainability, yes, explainability, such as when used during the emergent response, we can use big data to analyze the people movement patterns, to assessment the serious the risk ranging people number. But when you apply the AI to solve this problem, and we found it is in some time because the disaster area is complex. In some time, we can't to show the detail of the people movement patterns. Thank you.
Yeah.
Yeah, my question is around the last presentation. I just wanted to understand how significant it is monitoring desert locusts for the early warning mechanism for disasters. So how much significant is that in providing that mechanism? Thank you.
Thank you very much for you and very good and Christian comments. And just as you mentioned, and for example, for the desert locust, because desert locust and is a transboundary, and it will and it will fly also with the wind from one country to another country. Yeah. And we also get some cooperation with LO. For example, we will try to monitoring about and where is the high risk about these areas, and we just to try to monitoring about it because and especially in some desert areas, and maybe some areas maybe people cannot go there, and we shall try to find it by satellite and focus on the habitat conditions, because the desert locals they will have the different habitat conditions. For the habitat conditions, we will focus on different factors. We shall try to, and some factors just like the vegetations or the moisture or the rainfall. So some abnormal the rainfall, also some areas. Then we will know and how about this and high risk and areas. Also, we'll also get some cooperation with LFO. There also comes some field survey. Then we can try to combine with them together. And also for them, and just like the meteorological and forecasting, because maybe this year the temperature is rising very high, and so it will be early. So by doing this, we can try to forecasting it, and just before, and just I mentioned, maybe now we can within and just about 30 to 10 days before for the forecasting. Also in some Somali and Ethiopia and Pakistan, it can reduce the pesticide application and for more than 20%. Also increase the biodiversity more than 10%, just like this. Yeah, thank you very much. Any other questions or comments? Okay.
Hi, thank you for the presentations. I just have the question about data. I think both the first presentations measure that we have a bottleneck over insufficient data. So, but also a deep integration over space and ground data. So are we focusing in creating more like validation data on the from the ground, or are we integrating more models to generate validated data, if that makes sense? Thank you.
Yeah, I would like to say this is a really good question. So generally speaking, when we derive very important parameters from the satellite images, we already rely on the ground-based tools to validate our algorithm. So generally speaking, we do need a very large investment in producing large-scale in situ dataset as a kind of ground truth validation and also, benchmark. So that's the reason GEO is calling for attention on a new in situ data strategy and looking for global sharing and a global coordination on introducing large-scale in situ dataset. And on the other hand, I would say, with AI, with advancement of AI, we do see a new opportunity where generative data could be a kind of another source that we could rely on to validate the traditional satellite-based measurements. However, how we could effectively utilize the new technology and to which extent that we could rely on the generated data as a ground truth, which is still not very unclear. So that's the reason I would say AI, open the door for many good opportunities, but we are still on the way to find, the final applicability and usability of that technology. And so that's the reason Geo take a kind of, very secure and also solid approach with promoting, the ground truth, data sharing, and coordination was recorded in the CITO that, that strategy, which is going to be discussed and goes the 28th day tomorrow. Yeah. Thank you for this question. Thank you.
Yeah, I think that also just you mentioned that for the validation is very important, and also just and for our research also mentioned that and some international cooperation also very important. For example, for our research, we have also get some data from FAO because the FAO has some member countries. Then FAO has some field survey in some different member countries, and we also get some cooperation with FAO. Then we can get some field survey data from some different member countries. This can also for the validation, just like this. Thank you very much. That's very important, just you mentioned. Any other questions or comments?
Okay, thank you all the speakers. I'm not sure my question is directly asked as anyone to make answer. I just want to raise this the question. When we're talking about the Earth vision and also the AI tools, yeah, it's very powerful. So for us to make it a new paradigm of the disaster mitigation or reduction. However, I think it's I'm thinking as another one question is what is the real needs from the end user? For example, from the community, from the local government, and even from the public. What's the real need? The AI tools or the AI-based service. What's the? I think it's a quite important question. Is our core design is mostly based on the requirement from the big organization, from FAO, from the UN. And we also need to think about what we really can do for the end user, for the local communities. So I think because we know that the AI is the computer power consumers the model. So if such a tools can be used for them, how can they use them? And I think the question should be answered by us. Is a part with our work is for the big organization. Okay, thank you.
Yeah, I think that Professor Lin, and you have get a very good question on comments, and just you mentioned that how can we face and solve the end user's problem? That's very important. And just as you mentioned, maybe for the decision makers or for the end users, for example, maybe for some farmers or maybe for the global scale or the national scale or the local scale, their needs will be different. And also just mentioned maybe, and we should try to use AI, and how you can maybe for the different users to use this. And for our I think that research we can try, and for example, we just get some, for example, we get some cooperation with the FO for the use for FO use. We can try to support some just like metro debt for the FO, but for some end users, especially maybe for some African countries and for some to do this, we will try to support some just like mapping about this. And they just about maybe about this and disasters conditions mapping, just about the series different mapping, just to do this. So just as you mentioned, maybe how to do this, also how to use this AI for the application, that's very important. Maybe for the different end users, maybe the methods will be different. Dr. Yang, do you have any comments about this?
This is a very important problem. It's a question, good question. Because in the disaster management and for the disaster management, the most important thing is how to improve the efficiency. How to improve efficiency. Of course, remote sensing can solve some problem to support decision making. But if only use remote sensing data to solve this problem without AI, I find the efficiency can't be improved. After use of the application AI plus remote sensing, we found it can improve the efficiency for the decision making, and it can improve the accuracy for decision making. So we found the AI plus remote sensing is powerful in disaster management. Thank you.
Yeah, and thank you very much. Do you have any other questions or comments? Also, I think that some comments also are very welcome. Thank you.
Comments about AI. The explainability of the AI is important for developers, not for the end users. This is my my humble idea. Let's say, yeah. Let me. Maybe if I finish my comment, you would have a different idea. But we deal with end users. For example, let's say the final user of the software is the farmer that is going to irrigate his field.
Yeah.
And he needs to know the information about the amount of the groundwater, amount of the amount of the rainfall, the difficult word. And then he needs this. If you rely on your AI model and you know it's going to work, it's going to give you the precise information about these factors, you give them this report, let's say, or a simple plot that they can understand this. They don't need to go through the black box of the AI that you are developing, no? They need to know if it's going to be enough water for the field. So if you rely on your model, you know that the explainability of the model is important for you and you understand it, and you can explain it to yourself, this is already enough. You don't need to pass this black box to a farmer that doesn't have the knowledge of opening this box. And they don't understand this black box. They understand if it's going to be water or no. So if you rely on your model, then it's enough. You explain it to yourself, to the developers, to researchers, to those who are technical person, but not to end users who are going to use these results at the end. Okay, this was just a personal comment.
Yeah, you know, it depends on user, because maybe farmer at the field is not, he believes you, he trusts you. But if you try to sell or to provide your technology, your solutions to government, they require explanation. They don't want black box. They want explainable AI. So it's not always the case. But regarding the question of Lee, who is needed artificial intelligence and when it is needed. I can say from my experience, I'm from Ukraine. And Ukraine now is struggling in the war. So our government, our Department of Statistics doesn't have objective information from the field about agriculture, about areas, about crop yield, so on. But government requires this information. So we use AI models to estimate crop areas, to estimate crop yield in our Ukrainian territory and occupied territory, and try to understand what is happening there. It is one question. So sometimes some territories are not available for in situ observations, for direct information gathering, and AI can help here. We should understand that it could be some uncertainties and so on, but it is the case when we can get this information. And another example also from Ukraine. Now we are on the way to European Union, and European Union has very good system of agricultural inventarization. They have digital maps of every field, and they collect information what is grown at every field every year. In Ukraine, we don't have this digital cadastre. Our cadastre is not correct. We have some, but it is not correct. There are many mistakes there. So we use AI to build field boundaries automatically, to use computer vision techniques for field boundaries delineation, and use it as a proxy of digital cadastre system to provide farmers with subsidies to implement the practices of supporting farmers. And at this first stage, it is a solution because field boundary delineation for big country, and Ukraine is a big country, is the biggest in Europe, it requires few days with AI. But if you try to manually delineate all the fields, it requires thousands of person months. So it's impossible in this situation. So from my experience, AI is helpful where we cannot get exact, precise information from ground. Yeah.
We work closely with the government in Catalonia. So we are the supporter of the space sector in Catalonia to connect the downstream side to the government. And we deal with all this discussion every time we have meetings with, let's say, authorities. What they don't need to understand. For example, let's say if you want to explain, this is the reason I'm saying that this year we will have less water than the previous year. They want to know the last part of their comments, that this year we will have less water than previous year. This is important. And then it's up to you as a developer to trust what you say, no? You have to explain to yourself, not to the end user, that this is why I'm saying that AI is important or is doing the good job here. So maybe I put my word in the wrong way in the beginning, saying that the explainability is not important. It is important, but for those who are dealing with the backbone, with the technical side of the AI, not the end users, because they need to hear the right word from your side to be able to make the good decision, for example, to manage the water distribution for farmers, because at the end, farmers are going to the government, not to the people that are developing the AI, no? So this is, the explainability is important, but in the research side, not in the economy side.
Let's not become arrogant just because we understand AI. We are the expert on AI, but please don't become arrogant. I will dare anyone in this room to go to a farmer to say, stop planting potatoes because my model says that you have to plant carrots. You will never get that. Please don't become arrogant because we are the expert on the language. We have to be the forefront to explain, not to assume. We are not in the ground. We are not in the field. We assume everything because we use air observation. We are not in the field. We don't have the experience of living in those conditions. So simple as that. We will never be able to tell a farmer, please change your plantation because it's not what my model says. They will just close the door in your face and say, good luck with your model.
Yeah, I would like to take this opportunity to jump in for a quick comment. Where I think this is a good opportunity to revisit the Earth's intelligence. The definition, as explained in the post-2020 strategy, Earth's intelligence doesn't mean AI. Earth's intelligence means informed strategic decision. It's the outcome. However, the AI is the path that we select or we prefer at the moment. But the fundamental goal would be informed decisions. So it is that informed decisions is something that we would like to pursue other than the path, when A or B. The second keyword is trustworthy. We mentioned about it for several times, but for so many years, when we think about data products, it is very populated and so many individual research teams are producing a variety of data products. However, if you have a chance to examine in the same time, same temporal, same semantic, you will see a dramatic inconsistency between these valuable data products. So that's the reason, along with the definition of Earth intelligence, we're also paying attention to trustworthy data products. So basically means we could rely on AI or not AI, but what we right now need is a trustworthy data products as a first step. And then we're coming together to find and reach the informed decisions. So that's the reason in the post-2025 worker program, they introduced a research to operation mechanism, which is a brand new signal, not just a research and development. Could produce your product with the designer, with the users. And if we are talking about something operational, basically means you have convinced your users with your system, with your AI, and with your data products. Other than nobody will go with you. So I think this is a very good discussion, and we can take full advantage of the power of AI, but AI is not something products they can just sell. You need to co-produce, co-develop a solution with the end users to get some trustworthy products with whatever methods, and finally reach the informed decisions, and that's something we will have to go in the next 10 years. So that's something I would like to put on the table and hope it helps. Thank you.
Yeah, and I think that thank you very much for you and all of you very good and Christian also comments. Just that due to the time limit, and we will now move into the closing remarks. Now I would like to invite Director Strain and Young to deliver the closing remarks. Let's welcome Director Strain Young to making the closing remarks.
Okay. Thanks to Professor Huang. Firstly, lots of thanks to GEO to give the opportunity to hold this session. Just now, 4 experts have given wonderful presentation. Among other 3 experts, Professor Bei shared some work and idea on application of AI in wildfires. Professor Zhou shared excellent work by using LiDAR data in meridian predict. Professor Huang shared wonderful presentation of AI application in agriculture disasters. Lots of thanks to our colleagues to share good questions and good ideas. I think it is the common points for all of the application of AI applied in disaster management. Not only in disaster management, but also in other fields. I think just we discussed the points is the common points for AI application. We know disaster reduction is the community, it's a common challenge and the tasks for all the humanity. Remote sensing is the most important means to provide support for disaster forecasting, losses assessment, and so on. AI is the developing modern technology. It can empower remote sensing to improve the capacity to solve lots of problems, such as losses information and risk information extraction, disaster early warning, disaster predictions, and losses assessment, and decision making, and so on. Therefore, AI applied remote sensing is the main direction for disaster management. Of course, we know AI is just the beginning. It is just the beginning for AI application in disaster management. And lots of problems should be studied to solve, such as how to improve the explainability and generalization we just discussed. I hope AI can play much more important role in disaster management day and day. That's what I should show here. Thank you.
So, and that's all for this session. Thank you very much for you and all you and come to this session. Thank you very much.